Hi everyone, today we're going to talk about translations, which is section 12.2. A translation is a slide. It is an isometry where the pre-image maps to the image. The orientation is exactly the same. So for example, if I label this ABC, you'll see that this is in what direction. This is clockwise, and that would map to ABC prime in the same notation, or rotation I should say. It's also clockwise, so it has the same orientation. So it is an isometry and it has the same orientation. A translation is a slide. Okay, we denote the slide using two different formats. We can use a vector notation, and then we can also use a coordinate notation, which I will show you. We note whether it's moving to the left or right, or up and down. Here is another example of a translation. The pre-image maps to the image, and again, notice your notation with ABC prime notation. So let's get into the nitty-gritty. Let's go to your packet. So a translation, the definition, a translation is a transformation along a vector that such each segment joining a point in its image has the same length as the vector and is parallel to the vector. So how do we create freehand a translation? So I'm going to just walk you through the process, and then hopefully you'll be able to do it yourself. You will need a ruler. And so the first thing that you want to do is you want to draw a line from each of the vertex points that's parallel to this vector. So right now, just draw, again, what I try to do is I try to line this up and I slide it up to the vertex, and then I'm just going to draw a ray right now. And I'm going to do that for all of them. So I'm going to take this, kind of keep it in position, move it up so hopefully it's parallel to that vector, and draw myself a ray. And then I'm going to do the same thing here and draw myself a ray. Now the key for a translation is now you're going to measure the length of the vector. So this is vector notation. So the length of the vector from the tip of the arrow to the vertex, measure that with a ruler. So I'm using my centimeter ruler, and from here to here it's 3.3 centimeters. So that's where the new point is going to be here. And then I'm going to do the same thing, 3.3 centimeters. I'm going to mark off. So let's label this. If I label this A, B, C, D, that might make it easier. So this new point is A prime. And then this one's going to be B prime. And so again, what would you say? 3.3 we said is our vector length. So I'm going to mark off 3.3 here. And mark off 3.3 here. And then I'm going to connect them. And I'm going to create my image. So I think using a ruler is probably better. So that's my C prime, and then that's my D prime. So that's how we would create a translation using a vector notation on an open plane surface. Now, if we are going to use it on a coordinate grid, this is the vector notation that you're going to see. A represents the horizontal change, positive, negative. B represents the vertical change, up and down. So for example, if I had a vector of 3, -2, it means that I would move my given point 3 units to the right and down 2. So this corresponds with the X movement, and this corresponds with the Y movement. Okay, so just some general statements or rules. So if I have a vector A, 0, that means that there's no change in the up or down, but there's a change either left or right. Okay, so how we would note that is if I had a coordinate on my plane, then my new point, P, I'll call it P prime, is going to be x plus a, and in this case it's going to be y plus 0, so it's just going to be y. That's my new point. Okay. For a vector that is 0, comma b, it means that the new point, P prime, is going to be x plus 0. There's no movement on the x. And in the y, it's y plus b. And for along a vector where there's a change in both the x and y, we're just going to add those values to the given x and y coordinates. So my P prime here would be x plus a, y plus b. So now let's take a look, and let's jump to number 4 here. So the first thing I want you to do, put the video on pause. I want you to graph the triangle GHI, and then I want you to move it or translate it along the vector -2, comma 0, which means you're going to move each of these coordinates 2 to the left, and there's no y change. And here for part B, you have a quadrilateral, and you're going to move it by a vector -4, comma 5. So you're going to move it 4 to the left and then up 5. So put the video on pause and see what you can come up with. So hopefully you're all back, and I want you to take a minute and check your answer. Make sure that you have your original triangle labeled as GHI and your new triangle as GHI prime. And here's your quadrilateral. So I hope you're able to do those well. So let's take a look now at some of the other issues or topics that you're going to see in this section. Okay? So I'm going to shift now to this. Everybody take a minute and read this. So what's happening here is that the boat is making 2 changes, 2 movements, 2 translations. So the question is can I express those 2 translations as 1 translation? So why don't you see if you can draw a diagram to represent this, and come back when you're finished and see if you can figure out what your answer is. So let's take a look and see what you did. So my original boat has the coordinates of 100 west and 5 south. And then what did I do? I traveled 50 west and then 10 south. So where am I compared to the original position? So your original position is 150 west and 15 south. So the vector would be -50, -10. And so this is your vector notation. They're like little inequality symbols, so don't forget to use those in terms of your notation. The next concept that I wanted to talk to you about is magnitude. The magnitude of the vector is the length of the vector, and it can be found using the Pythagorean theorem or distance formula. The magnitude of a vector, if I tell you that the vector is a comma b, then the length of that vector is the square root of a squared plus b squared. So, as an example, if I have the vector of 5, 12, if I plug that into my formula, the square root of 5 squared plus 12 squared, that's going to give me a magnitude, the length of the vector, of 13. Okay? So, we already did number 4. And so let's jump on down now to number 5. Let me go to this page. Sorry about that. Let's go down to number 5. So number 5, my initial position is at 3, 4. And I'm going to move up 2 spaces. So how would you represent that vector? That vector, hopefully you got, was 0, 2. If I'm moving up 2 spaces. And then I move 3 spaces to the left. So that 3 spaces from here, I'm moving in a negative position. Okay? So I would say that from my position, then I'm going to go -3, 0. So if I wanted to combine both of those, I could make a single vector. So the single vector would be -3, 2. So the question is, where am I with respect to, if I was originally at 3, 4, where am I now? So hopefully you can tell me that your coordinate, if I call this P prime is going to be where? Has everybody figured out an answer? Hopefully you figured out you would be at 0, 6. Okay? So when we have 2 movements, that is referred to as a composition. Or we could have 3 movements. It's still referred to as a composition. And we'll talk more about compositions in section 12.4. I hope you enjoyed this. Talk to you later.